I decided to start this PowerPoint presentation, which was prepared by my colleagues from the structural group, by getting back to these LPIs, etc., in order to explore this in their approach to the structural vulnerability definition. So it's really what we have been talking. So we are talking about settlements, movements that can be related for some approach with the factor of safety, which is in fact what we have here. So LPI was already introduced, is an index, a potential liquefaction index, that will try to aggregate in depth a factor of safety defined priorly by Giuseppe Modoni, Professor Modoni, and I think eventually him. So if we have that, even Vincenzo, when he showed these profiles with the CRR and the CSR, independently of the two different results, and then we get this factor of safety in depth. And if we have that, we can get this integral of this factor of safety towards that liquefaction. So as much as we have, I mean, the higher is the factor of safety, the less we will have to in the integer. It's not contributing to the settlement or to the collapse. So it's less vulnerable. So when it gets lower and lower and lower, it will get higher in this integral to 20 meters. So in the end, it is a class of potential associated to only to a factor of safety, but that should reflect a movement, a displacement, a settlement. Very old definition from our colleague Japanese Ayazaki. Recently, sorry about the format, because I imported these slides to the one that this afternoon, and then it was not formatted. So this one was already commented here, was developed quite recently by the colleagues in Canterbury, in New Zealand, the group from NISCO, and they definitely went towards the settlement without emulating it in a factor of safety. Why? Because they introduced this LSN, which is in fact a severity number, but directly connected to settlement. Of course, it is the old volumetrical approach for settlement. We should have better, but still it is a measure of collapse due to liquefaction. And then they developed this with different approach, different levels, which you can see here. The only thing that could eventually be developed in the next years is trying to evaluate if the Zhang and all proposal is still a good proposal. And you can see that this value of the deformation, the volumetric deformation due to this phenomenon, is based on this database that they collected. And it's related to this limited strain, which is this epsilon VI, is a post-liquefaction volumetrical strain for each subsoil layer. So you can go to the CPT profile, you can get all these values, and you can go to the LSN. Step forward of the LPI. Can you see at least that is there? Idris and Bologna, they was based on this limiting shear strain again, which is the maximum shear strain and the post liquefaction strain, and they developed a little bit further in the definition of a post liquefaction settlement. So it was an evolution towards the Zhang et al. Proposal. So we just have to go to a limiting shear strain where the liquefaction occurs, which is defined again based on the CPT. the one that we talked this morning, it is a normalized value of the cone resistance to take into account the state condition in relation to the clean sun. Too complicated? Not so much. I mean, the only thing that you have to do is some kind of a correction when you have fines and you get this value. That's it. So with this in mind, with the CPT profile, we can have this limiting shear strain in each of the layers that you divide your tests. So then they propose this, relating with those case histories of the post-liquefaction strain would be defined by this expression with some variations here. I mean, if you have a factor of safety higher than 2, that's okay. If you have a factor of safety between this one, the one that would define a post-liquefaction strain, which we should be aware of, then you have to consider this value here. And finally, if it is very low, that's the post-liquefaction, the absolute strain. So it's like a spreadsheet that we developed. So in the end, you have the volumetrical strain, which is a little bit better for their proposal than the one that Zhang et al. Defined in 2012. And the settlement is just an integer of these volumetrical strains in depth, multiplying the thickness of the layer. So we are worried about the post-liquefaction displacement settlements. In this last slide of the previous morning that I didn't have time, we also have at least some information on how to predict a lateral displacement from this old, already 12 years, Zhang and al. Proposal, which is the lateral displacement index, and he defined this related again to the maximum cyclic shear strength, and that's what we have before defined. And now I go to I will not do these questions because it was related to the morning session. Then I ask our colleagues from structures to think a little bit about what we will do after looking at the references, I mean the bibliographic, the reference in the bibliographic references, what are the motivations and the strategy that we will look for with this WP3. And then I was with them this last week, and then we finally got this presentation here. So in this WP3, we will be having structural liquefaction resilience and vulnerability assessment methodologies with 3 sub-working package tasks. The first one will be the evaluation of the existing numerical strategies that we are already doing. They have been working in this. And then we will have the following ones, that is trying to evaluate the liquefaction vulnerability analysis with interacting structural soil systems in the fields related to the pilot testing sites where we will do our tests. But look, I mean, what we have here is that we do have these conditions. So if you have a strong earthquake, we can have the collapse. But we have here some examples of typical things that are almost due to liquefaction alone, eventually here, but then here you have mostly sure you have an effect of the shaking prior to the collapse of the settlement post-liquefaction. Eventually, that's what you had here, and perhaps what we have here. We don't have a unique damage associated to the settlements. So these people from the structures, the first thing that they want to do is we should try to identify the damage in the structures, wherever they are, coming from the shaking prior to the liquefaction, because that's what happens. in these first cycles of the movement, you can have an immediate shaking that can damage your concrete, your beam and piers structure, and then after that you will have the settlement due to the collapse of the post-liquefaction. Because this alone happens, but this can also happen. I mean, the shaking and tilting causes some structures to fail. And then you can stay with this alone, final period, or you can have the post-liquefaction. So we have to be at least we have to look at the two phenomena. So in numerical approach, this is quite tricky, because you eventually will have to have these programs. I mean, we're thinking of using Babacos, Midas, and other things that we will discuss tomorrow in our partners meeting. But then we have this damage associated with a period. Then we have to do a decoupling, and then we will have to incorporate the post-liquefaction consequences. So we have different conditions. We have low probability of liquefaction. But if we look at this, I mean, it's just shaking, and it's shearing damages. Damage controlled by the ground motion. Then you have high probability of liquefaction by itself. Eventually, it was a very rigid foundation. We look at that with no analysis, very detailed analysis. We think maybe this is completely integer. The building seems to be perfect, but it tilts. And then we have the mix of the two. So settlement due to the liquefaction after the damage due to the ground shaking. And we have to deal with this numerically, and then to try to get a very simplified approach to the problem. So if you have a reinforced concrete structure, we will have, typically simplifying, foundation type like flexible foundations. That's the damage that you would expect from this situation. While in a flexible foundation, the typical Niagata movement. And that's the thing that we are putting forward or pushing forward now. So they got this from a paper, a well-known paper, but I think it is very interesting for us to analyze. So if you have the building, the classification, and we are, at least at the moment, we are only worried about reinforced concrete, generally reinforced concrete situations, at least in this first approach. So we have flexible foundations, you have all these uniform vertical, differential vertical, etc. But the structural damage will be possible by analytical solutions. In stiff, shallow foundations or floating piles, very common in some of our structures, we have all these modes of ground deformation. Rigid body is expected. So empirical solutions, the one that we talked before, the LSCN, etc., will fit, we think. And then we have these piles to firm, which will be outside of this work. So we have to deal with two different situations, flexible and stiff. And how come with the performance levels and corresponding ground deformations? For what they recoiled in the references that they found, there is not so much information on these damages due to liquefaction. It's really good to look at this rigid body movement modeling liquefaction building damage in earthquake estimation from 2006, which was already shown by Giuseppe Modoni this morning. And we can see here the damage state, the structural damage, etc. And we can see that it's already well defined, but it's the rigid body only the rigid body. And okay, we should be worried if we have more than 1 meters in settlement alone. We should be very, very worried if the rotation is in between these 40.6. I don't know if this is 4.6, but that's the number that is there, or higher than this. All these will be extensive, moderate, and slight. Don't care. But this is only what we found published on rigid movement, body movements for these performance levels. But if we look at these here, the classical differential deformations due to severe or moderate or slight damage related to the horizontal strain versus angular distortion, this is very, people that work in tunneling, they know that they have to work on these proposals. We should use both for the double step damage. So in the end, that's what they are looking for. I mean, we have to do 2 steps analysis and try to integrate these informations from the references and try to define these vulnerability levels. So in the end, and summarizing, step 1, we will do a detailed modeling approach, development of a detailed finite element models of small size reinforced concrete structures and soils, including liquefiable layers. And then we analyze the effects of these 2 steps. It's very heavy. It's very heavy numerical calculation. The step 2, we will have to follow a simplified modeling approach, which we think is not enough, the ones that we have, the ones of the LSCN, etc. So we have to do a simplified approach to be in the proposals that we will have in the manual. And finally, we will try a probabilistic analysis where it will be something like this. This is the probability of failure, and this is a measure. Which measure? We will look for that. Let's see what happens. That's what we will work in the next month, starting on November, I guess. Okay? So, the only thing that I would like, I have a film here that I will not present that is very clear, because I don't have time, no, you don't. in Christchurch, where it's very, I invited you to go there. Sorry.
So we got an earthquake.
It's a very funny 21 minutes movie that you see that in this house, the guys are already used to the shaking, and then they began to do the fishing due to the shaking, and then they were marvelous with water, and then the water, okay, it's nothing, it's very funny, etc. And then the collapse is prior to that. So the 2 things are there. It's worse to go there because it's a 2 steps movement. Thank you.
Thank you, Antonio.